In this video, we are going to learn traverse calculations in civil engineering and construction. In construction field surveying, traverse stations are used to establish points and lines for control networks. Construction traverse surveying can be open traverse, like in road and railway network. It can be closed, like in fences and building construction. There are different software that can help with this computation. However, in this video, we are going to learn manually what the computer does behind the scene. Traverse calculations in civil engineering and construction used in land surveying. To understand this step-by-step calculation, let's take a practical field traverse surveying question. Consider a construction site which will be surveyed. The surveying was completed and the following data was obtained. In the calculations, we are going to balance the latitudes and the departures for the following traverse. To understand this calculation, let's consider some basics. In the planning and design of all civil engineering projects, surveying is a basic requirement, such as in highway construction, bridge construction, tunneling, in dam construction, airport construction, in the construction of railway tracks, for street lane markings, in stadiums construction, tennis court construction, power transmission using pylon, in water, oil, gas transmission and distribution, for building construction, and many more. Construction traverse surveying can be closed or open. It is closed like in a building project, or open like in road construction. To solve this problem, the first step is, at each station, draw a horizontal and vertical line like a cross. Next, step number 1, draw a traverse surveying table like this. Step number 2, fill out the table headings, starting with the sides, then the bearing, the length, the latitude, the departure, the corrections of the latitude and the departure, and the balance for the latitude and departure. Next, step number 3, fill out the side columns, that is, station A to B, station B to C, station C to D, station D to E, and station E back to A. Remember, it's going to be a closed traverse surveying, that is, A to B, and from B to C, and from C to D, from D to E, and from E back to A. Step number 4, fill out the bearing column. A to B is south 6 degrees 15 minutes, which is represented from A to B. Next, you fill out other stations respectively, which are all this. Step number 5, from A to B is 189.53 feet, which is this. Next, you fill out B to C, C to D, D to E, and E to A, which has been completed here. Next, step number 6, sum up the length column, that is, A to B is added to B to C, is added to C to D, is added to D to E, and is added to E to A. And this will give you a sum of 939.46. Next, you call this total capital L subscript T, where the T is the total of the length. Next, step number 7, calculate for the latitude column using the appropriate formula. To solve for the latitude and for the departure, let's understand the formula to apply. Another name for latitude is northing, which is basically the y-axis, and for departure is easting, considering the x-axis. Subsequently, to calculate for latitude, the formula is plus or minus the length of the side multiplied by the cosine of the bearing, which is theta. Likewise, to calculate for the departure, the formula is plus or minus the length multiplied by the sine of the angle, where theta is the bearing under consideration. Hence, to fill out the latitude, we are going to require this formula: plus or minus length multiplied by cos of the bearing. To calculate for the latitude of A to B, we are going to need the bearing of A to B and the length of A to B. Hence, the latitude for A to B is plus or minus the length is 189.5 feet multiply the cosine of 6 degrees and 15 minutes. How are you going to do this using your calculator? In your calculator, you type 189.5, then you press multiply, then you're going to press cos, open bracket, then you're going to type 6, then you're going to press this, then you're going to have something at the top. Next is you're going to press 15, and next you're going to press this again, and you're going to have this. Close the bracket, and you are going to press the equal sign. If you do this correctly, you are going to get 188.403. It must be to 3 decimal places. That's how this was obtained. Next, will this be a minus or a plus? Let's consider the line going from A to B. This is A and this is B. The start off point is A, so I'm consigned with the point of A. This is west and this is south. This is east and this is north. This line is in between the south and west. On the west side, this is minus the x-axis for departure, and for the south, this is minus y for latitude. Hence, because I'm considering latitude, which is the y-axis, this we have a minus. Hence, for A to B, my latitude is going to be a minus, and my departure will also be a minus. Hence, A to B will be a negative. Hence, that's why this latitude is negative. And for the departure, the same length for A to B and the same bearing. The difference is there is a sign. To compute this in your calculator, type 189.5, next multiply, next sign on your calculator, then next type 6, which is this, then you press this, next you now type 15 and you press this again. Close the bracket and press the equal sign. If you have done this carefully, you are going to get 20.634. Now let's consider if it's going to be minus or plus. From A to B, the departure is negative. Hence, here is going to be a minus. And here we have gotten our latitude and our departure for side A to B. We are going to repeat this for B to C, C to D, D to E, and E to A. Many students do not have problem with this formula. The problem is when is going to be a plus and when is it going to be a minus. For each of the stations, there is a north, east, west, and south. After including your north, east, west, and south for each station, next, you consider your normal mathematics Cartesian plane, where this is plus y and this is minus y, this is plus x, and this is minus x. Same, here is going to have a plus, here is a plus, here is a minus, and here is a minus. Next, always remember that this line, which is the vertical line, is always your nothing, and the nothing is the same thing as latitude. Likewise, the horizontal is always your easting, and the easting is the same thing as departure. For example, let's consider B to C. You can see that B to C, your departure is a plus while the latitude is a minus. So you are going to consider that after you have calculated with the formula. From C to D, it is northwest. The north is a positive and the west is a negative. From C to D, your latitude will be positive and your easting, which is your departure, will be negative. Consider this in your calculation. Next, consider D to E. D to E is northwest, and this is the north and this is the west, hence the line is here. And you can see from here that your nothing, which is your latitude, is going to be a positive, and your easting, which is your departure, is going to be a negative. So here we're going to have this positive and this is going to be negative. Next, consider E to A. E to A is northeast. This is north and this is east, so it's going to be drawn here. The departure is going to be positive and the latitude will also be positive. In step 7, you are going to complete all the latitude using the formula, considering whether if it's going to be a positive or a negative. Step number 8, sum up the latitude column. You call this error on the latitude. Remember, this is the total length. In step 9, you're going to calculate for the departure using the departure formula, and you will consider if it's going to be a negative or a positive. If you do that correctly, you are going to get all the values for your departure. Next, sum up the departure column, and if you sum everything, you're going to get this, which is the error in the departure. This is the error in the latitude, and this is the total length of the sides. This will be very helpful when we are going to be calculating for the corrections. Step number 11, calculate for the latitude corrections using the appropriate formula. To calculate for the correction of the latitude, it is negative of the length under consideration multiply by the total errors of the latitude divide by the total length. That is, the negative of this length multiply by the total error of this latitude divide by this total length will give you 0.016. If you do this correctly, this minus is always in the formula, but this minus came from the table, and you're going to get the correction for A to B is 0.016. Now you have known how this was obtained. Let's try for the correction of B. Try for BC using this length, the total length, and the total error. Still on the correction of latitude, this negative is always permanent. The negative is with the formula. If you do this correctly, you should have 0.015. Always remember this negative, and this negative came with the total sum of the error of the latitude, and that was how we got this. Using this same formula, you can do for DC to get this, for DE to get this, and for EA to get this. Step number 12. Calculate for the departure corrections using the appropriate formula. For the departure, it is the considered length. It must not always be AB. It can be BC, it can be CD. Multiply by the total errors sum of the departure divide by the total length. Let's consider AB. For AB, we're going to consider the length, and we're going to consider the sum of the errors of the departure, and we're going to consider the total length. Remember, this minus is in the formula, and this minus came with the total sum, and this becomes 0.033. That's how we obtain this. Let's do that of EA. EA will consider the length of EA, the total length, and the total error of the departure. If you calculate the departure correction for EA, you're going to get 0.041, which is this. When you have completed the corrections of all the latitude and the departure, next, step 13. Calculate for the latitude balance for side AB. The earlier latitude plus the corrected latitude will give you the balance. Next, for BC, the earlier latitude plus the corrected latitude will give you the correction of BC. Next, for CD, the earlier latitude plus the corrected latitude will give you the balance, and you can do same for others. Next, step 14. Sum the latitude balance column. That is, this plus this plus this plus this plus this. If you compute this very well, you are going to get this to 3 decimal places. Next, for the departure, the earlier departure plus the corrected departure will give you the balanced departure. For BC, the earlier departure plus the corrected departure will give you the balanced departure. You can complete same for others. Next, step 16. Sum the departure balanced. That is, you sum each of these. If you do that correctly, you are going to get 0.000 to 3 decimal places. In conclusion, this calculation is balanced, and the traverse calculation is correct. If you do this with a computer, you are going to get the same answer. The problem many students encounter usually starts with the earlier departure and latitude. Once you make mistakes with your departure and latitude, the mistake will overflow to the corrections and the mistake will also overflow to the balanced. And at the end of the day, you might end up not getting a balanced calculation. In our next video, we're going to be looking at calculations involving height of collimation method and rise and fall method in civil engineering and construction. Make sure you check out other videos involving civil engineering, construction, and land surveying calculations. I will see you in the next video.